Hey everyone, in this video, I want to look at some of the capabilities we have when we think about migrating our storage from on-premises to Azure. What is the right service I would want to use in Azure? What are some of the ways I could think about then actually performing that migration? Because many organizations today are looking to migrate the storage into Azure. This could be because the application is migrating to Azure and we want the data close to the app for that lower latency. It might be I want to leverage cloud data storage and analytics capabilities. It might be I want to get the data into the cloud just so it can then be leveraged by machine learning, by AI. AI is introducing a whole set of cool new ways we want to use data. From an AI model, I can think that, well, with the workflow typically is I have to get my data, the raw data somewhere. Then I'm going to go and clean up the data. Then I might use it to train a model or fine-tune a model. But also when I have my AI application, I want to go and hook into the data as part of retrieval augmented generation. I can get very select pertinent data to send in the prompt to the AI model. And we need things like vector databases to make that work really well with the natural language which we normally think about. Now, as I alluded to, there's a number of steps when I think about the migration journey, and I want to talk pretty high level about them. I can think about, well, what do I have right now? What is the storage medium I'm using right now? What are my requirements? What are the options when I move to the cloud, to Azure? How do I think about mapping what I have today to what I can have in the cloud? And then once I've worked out the mapping, what is the mechanism I can use to move the data with ideally very minimal impact to my day-to-day operations? So step one is assessment. I have to have a very clear understanding of my key requirements. So I want to think about, well, what is my today? And I have to be super clear on exactly what I'm using and how it's actually being leveraged. I'll think about, well, what is the type of access that is actually being used to get to the storage? That's going to be a primary thing. For example, very often we'll think about, well, today, maybe I've got block-based storage. So maybe I've got some storage area network, and I'm then connecting that as a volume to some operating systems that then put their own file system on it. But I've got the option of, okay, I've got block. I also may have object storage, which I'm leveraging through various types of tooling. So I can think, okay, well, we have object storage. I might also be using a file-based storage. And files, generally, we're going to split into two different types. If I think about files, where the OS is just connecting to a file share, historically, I think about, well, we support the network file system, NFS, for Linux, and then SMB, KIFs, for Windows-based. Now, it's not exclusive. It's not always NFS Linux and always SMB Windows. There is cross-capability today. But these are going to be really common where I want some shared file-based communication for some kind of workload. So I need to understand not just, well, where is the data today? It's on a SAN, very common with block. It's on a NAS, very common with file-based. Maybe it's just local to some box. But how is it being interfaced from my application? Hey, I'm connecting to a file share. Hey, I'm mounting it as part of a volume on some server, for example. Hey, I'm leveraging this as maybe as part of some other analytics type capability. So I have to understand those things. And also, with all of this, well, what are the permissions on the data? How is it being used? What permissions do I need on it? So I have to understand what are the various permissions requirements that we have to be able to meet, because different solutions in the cloud have different capabilities and granularity on how I can control the access. I would want to understand, well, today, what is the resilience I have? I have copies just within a data center. I might think about, hey, I actually have a copy I'm replicating on a SAN. Maybe I'm using SRDF and I'm replicating it to a remote data center. So I have resiliency even from a data center outage. So I would want to understand, what are my replication requirements? Because again, there's many different options we have when we get to the cloud. A huge factor is going to be, what's the capacity? How much data do I actually have? And potentially, do I use tiering or could I take advantage of tiering? Because maybe I have a huge amount of data, but the reality is I'm only interacting with the most recent set of data. The rest of the data, I have to have it. Maybe I have to keep it for some regulatory reason, but it's barely ever accessed. I mean, it's a cold storage. I would want a cold tier capability. Or it's never accessed, but I have to have it for n number of years. So you might think about archive. I would want to understand, what is the performance profile that I need to support? And often there's different dimensions when I think about performance, and realize there might be the performance I have today, and I would want to understand not just what is the performance it's offering. I may have it on a SAN and it's got this massive amount of throughput, this massive amount of IOPS, but it's not being used. So you want to actually understand, because in the cloud, remember, we pay for really what we're using. So I don't want to over provision it, but also realize, how will it be used in the cloud? Because maybe I'm moving it to the cloud to take advantage of newer capabilities. So I need to understand my performance profile. And as I mentioned, we can think about throughput, the amount of data I'm actually moving per second, but also the IOPS, the input-output operations per second, because maybe they're very small operations at a time, or maybe they're really large operations. So maybe, hey, the throughput is fine, but it's actually huge numbers of very small operations where I would need to understand that, because that's very different than just having a certain throughput capability. So I need to understand those requirements. I may also get into latency. And again, there's different dimensions to latency. But what is the latency between wanting to go and get the piece of data and getting the response? Can I tolerate a millisecond, for example? There's also other special features that I may need. For example, in high-performance computing, we very often have parallel read-write requirements to the same file, which we may need special types of solution to support that massive parallel access to the same sets of files. I would also want to understand churn. What is the rate of change for my data? For example, is it mostly steady state with a small amount of delta changes every day? Or is the entire data set changing every 2 or 3 days? So it's got a massive amount of churn. That's going to be really important when we think about doing the actual migration and the amount of time we have to move the existing data. And obviously that would be very important along with the amount of data. So if it's really high churn and it's a huge amount of data, that might offer us some challenges when I do the migration. And what is the interaction with the data? Is it mostly read activity? Maybe it's very common. You get like nearly all of it is read, and maybe 5-10% is actual writes. So I want to understand, and there's assessment tools that would help me understand all of these different aspects to what I have. So step one, I have to understand what I have, but more importantly, what are the requirements around the data? Next, we could then think about, well, okay, what do I want to migrate to? So when I think about my targets, so if this is my today, I'll then think about, okay, give myself a bit of space. what is my target environment? Now, when I think about the targets, my focus really here is going to be about targets for storage migrations. And I'm only emphasizing that because there are huge numbers of storage solutions in Azure, but most of them, outside the ones I'm going to talk about, wouldn't apply to storage migrations. For example, if I'm using Azure VMware Solution, if I'm using AKS, well, there's things like Azure Elastic SAN that provides an iSCSI target. But typically, that's not going to be a target when I think about just basic storage migrations. But it does exist. So I just want to caveat, I'm not talking about every type of storage solution there is in Azure. I'm focusing on the ones that are going to be the common targets when I'm actually performing a storage migration. So the most obvious one here is going to be Azure Storage. Now, Azure Storage has a whole set of different capabilities. Most commonly, we're going to think about Blob. And specifically, Blob when it is the flat namespace, i.e., it's the regular Blob without turning on the hierarchical namespace, which gives you the data lake, which is the other option. Maybe it is data lake. And data lake is where I've turned on a hierarchical namespace. So the big deal there is it actually has a true directory structure. With Blob, you might see folders, but they don't really exist. The folder is part of the Blob name. And why that matters is if I do things like move files around, it's not moving it in terms of really a metadata operation. It has to copy and delete the blob, which is a pretty significant I/O operation, which is why we like having a true directory space with the hierarchical namespace where it literally can just move the file. You also get things like POSIX style ACLs as well with the data lake. Typically, that's going to be analytics. We'll talk more about that. Now, while we talk about Blob, and it's more of a specialized case, but there is also managed disks. So with disks, this actually sits on top of page blobs, but it's managed for you. But that may be a scenario that I want to leverage. And then the other huge capability of Azure Storage is files. So we have Azure Files. And this can offer both SMB and NFS. Now I'm saying and, I want to be careful. A share is SMB or NFS. It does not support dual protocol. Which brings us to a completely different storage solution would be something like Azure NetApp Files. Azure NetApp Files is NetApp filers in the Azure data centers as a managed offering, first-party resource provider in Azure. And what this provides me is SMB or NFS shares or dual. So it does have the capability that a single share can actually be accessed via SMB and NFS. It also has these different performance tiers. You can get up to super high performance. It has other features that are richer generally than just the basic Azure files. I'll talk a little bit more about that. But this is another very common target solution. And then another one we have, I'll do my line up a little bit, is Azure Managed Luster. Now, this is a super specific solution. Basically, you're going to know if you need it because basically you're doing a high performance compute scenario. Outside of that, you're typically not going to use Luster, but that's where it really shines, where I need that high performance computing. Because high performance computing, I have lots of nodes all working together on a certain problem. And because they're distributing the problem over the different nodes, they're very commonly all accessing the same data. So I've got many, many nodes accessing the same file. And traditional file systems and solutions are not great at that. Azure Managed Luster is great at that. It's really good at allowing massive parallel read-write to the same content. So that's the really big deal here. Now, I guess when we're thinking about all of those targets, the question is, well, which one do I probably want to use? Now, I'm not going to go into the weeds on this. There's some great documentation we're going to walk through in a second that can help guide you on this. But there are some very broad factors that I do want to cover that would help drive this. For example, managed disks. Well, the managed disks, if you think about where they are going to be used, well, managed disks are typically, when I'm using them, is some sort of virtual machine, which also means VM scale sets, which also means things like Azure Kubernetes service. So I'm typically going to get data into a managed disk to then be used by some virtual machine, by Azure Kubernetes service. If I'm creating a cloud-first application where I can define, or even I'm migrating an app, but I'm re-architecting it, if I can change how I interface with the data, very commonly what we're going to want to use for cloud-first is blob. So I'm going to think about these if I am cloud-first. If I'm starting from scratch or I get to change the app, typically we want to use blob, unless I've got some extreme performance or super low latency, which we'll get to. And the reason for this is it is just this phenomenally huge scale. And also I can use the API, which gives you access to this massive set of features and capabilities. So if I'm creating my cloud-first app and I get a choice, I'm probably going to use blob. Now, I'm including data lake in here, but realistically, data lake is primarily analytics, which again, you're going to know if you need it, because I'm creating it because I'm spinning up Snowflake, because I'm spinning up Databricks, and those want the data lake. So you're going to know if you want that. But at a super high level, if I'm creating a cloud app and I get the choice, for most scenarios, blob is a great solution. Huge amount of functionality, huge amounts of scale, and it has fantastic API to go and interact in many, many different ways. And then the data lake, I can still use the blob API, but then I can use the other APIs that I typically use with Databricks, et cetera, et cetera. So then you get into the file-based protocol. So this includes both Azure NetApp Files and Azure Files. I have some requirement that mandates the use of SMB or NFS. I don't own the source code. I need to run it as is. So what it typically means is it tends to be legacy. I'm taking a workload. I can't rewrite it. I can't change it to use the blob API. I'm taking it as is. Or it could be it's some solution which doesn't necessarily mean it's legacy, that just requires file-based access. For example, virtual desktops. Azure Virtual Desktop wants to use SMB. So it could be also, I just have to have file-based. It mandates the use of SMB. It mandates the use of NFS. When I'm in this scenario, Azure Files is typically a great fit, unless I get into I need super high performance, I need lower latency, or maybe I need a specific version of SMB or NFS, or I need specific features. And I'll show a little diagram of this in a second. So just to finish this chain of thought though, Lustre, you're just going to know you need it because it's HPC. It's all about the use of parallel write and read. That's where this shines. So if I'm in that scenario, I'm going to know I'm in that scenario, and it's just going to shine to, okay, I need Lustre. Fantastic. So now we can think about actually, and we've already talked a lot about this, how do I map these things together? And Microsoft actually has a really nice little document. So they have Azure Storage documentation. And it walks through a number of the things we've already mentioned. So I can think about here, it talks about different types of unstructured data. What are the migration phases? So, hey, go and discover things. Assessment, choosing the targets. And it's kind of talking about some of the things we've talked about here. How am I going to do the migration? We're going to talk about this. What is the tool? We're going to talk about that as well. But this little chart here, especially for the files based, notice it's talking about, well, can I use the API? This is what I was mentioning before. We'll go and use Blob. If it's latency sensitive, well, there's a premium option. If not, I can use standard. Can I use the REST API? No, then it's probably legacy. If I need a super low latency, then Azure NetApp Files can shine here. Otherwise, what is the file protocol? And this then comes down to if it's NFS, version 4.1 is supported by Azure Files, or 3 and 4.1 is Azure NetApp Files. SMB, they're fairly similar here. But then there are other capabilities as well that can actually come into this. There are some differences between what Azure NetApp Files can do in terms of encryption and permissionings, etc., compared to Azure Files. But this is a fairly nice little chart that can help understand it. Now, so if I start thinking about this picture and the mapping, let's do a different color again. So how can I think about mapping one to the other? If I'm using block today, so I'm in this block scenario, most commonly, probably in a SAN, I'm probably going to lift and shift it to something. And most commonly the way, because that block was probably connected to a server, which then did something with that data, which then exposed it to something else. So the closest mapping I'm going to have to my block is probably to disk. I'm going to lift and shift. Now, later on, maybe I can modernize it. Maybe I can go to blob or files or ANF. But most commonly, initially, if it was on a SAN and it was block storage, hey, it's probably just going to go to disk. If it was object storage, so Hadoop, S3, IBM GPFS, most commonly here for my object storage, well, I'm going to go to blob, maybe data lake. So I can think here, most commonly it's going that away. But if I have more advanced requirements, or maybe if it's analytics, it might go that way. So again, that analytics would help guide me. Okay, I want to go data lake. If it's any kind of network attached storage, again, assuming I can't modernize it, then here for these file scenarios, the whole point here is my targets are going to be those. So again, this is based on the assumption I can't modernize it. Typically, as you saw that little flow chart, I might think about Azure Files, but if I get to some scenario where I need better user access, better ACLing, I maybe want dual protocol support, that's where NFS is going to shine. So that's honestly some of these performance characteristics will come into your decision criteria about which I would use. And then again, the kinds of things you're doing, especially like super low latency requirements, probably going to be Lustre. And that, again, it's the way you're interacting. It's really about that parallel. So I'm a little bit hesitant to draw this line. It's probably Lustre though. If it's high performance computing, it's Lustre. Or there are also other partner solutions in Azure. I don't want you to read this as only latency, but sometimes when I have that super low latency requirement, and again, I'm really combining this with the type of access. So I can think about latency and access behavior. So that parallel read write, etc. That's probably going to be where we get into the luster. Okay, so we have this potential mapping, and it's fairly simple. Like the whole goal of this was I'm taking out a lot of the it depends, which is life. That's consulting 101, it depends. But now I can think about, well, how do I actually do the migration? And the options really do depend on my source, my target, the requirements of the migration. And one of the nice documents we actually have, if we jump over for a second, we can look at, there's a comparison matrix. So this is aka.ms/compare migration tools. And it can really help dial in the right approach. And you can see here, it talks about here the different tools. And one of the things to point out is, notice, yes, there's various Microsoft tools. So Azure Storage Mover is obviously the primary one. AZ Copy we'll mention in passing. Super useful for offline and seeding. But there's a whole bunch of partner solutions. And I'll explain why these are here in a second. But you'll notice they have different types of what it can do the migrations from. But it also goes into detail about, well, which Azure service is supported by the different tools. What are the supported sources for all of the different tools? You can see it down the bottom. What are the protocols that are supported by the different tools? What are some of the extended features? And this is where you'll start to notice a whole bunch of yeses in the partner tools, whereas it's mostly no's on the Microsoft tools. So that's one of the reasons that there's all these partner tools available. But this is a really, really useful chart to go through. And all of these links will be in the video description. Another really important thing I actually want to call out here is I said here can't modernize. Maybe we want to modernize. And you might think about, well, I'm here right now on some legacy solution. I want to modernize as part of my move to the cloud. When should I modernize? Should I modernize first and then migrate, or migrate and then modernize? Generally, the better option if I want to modernize is initially just move as is to the cloud. And then once you're in the cloud, then I can modernize. Because the benefit there is I get to just remove that legacy infrastructure as quickly as possible. But also, once I'm in Azure, I'm going to have better tools to do the modernization. I'll have lower latency as I start to move between the as-is legacy, maybe storage, and what my target is going to be. I'm going to have better abilities to move it, lower latency to move it, especially if there's churn going on. So for the most part, if I want to modernize, I would just move as is and then modernize once you're in there. So the next decision is, how am I actually doing this thing? So now I can think about the color should we use for this? What have we not used yet? Okay. So that's what I'm migrating. How am I migrating it? So we have these decisions. I have the idea of online, where I'm just copying it over the network. This could be via the internet, could be via my Express route private peering, or it could be offline. And most commonly when we think of offline, we're talking about Azure Data Box. I need to update my data box video. I think there's 120 and 525 with the new terabyte capacities for the new generation. They're these new rugged devices. But for offline, they ship me the box. I copy my data to it. I ship it back. And then they hydrate that data into my storage target. And they even support cross-region now. So I could send the data box back to the data center that's within my geo, but they could actually then go and restore it to a different region entirely here. Or it could actually be a hybrid. So one of the other options I can think about is, well, actually, when I think about offline, maybe I'm using the offline to seed. And that means the bulk of the data, I'll offline move it, but then there's still some churn, changes happening, and those I'll copy over the network. So what I can actually do is have a hybrid where I'm doing the bulk of the data move via an offline, and then the delta, the changes, I'll do online over my network. But there are some big factors here when I think about that. So one of the big things we have to think about is, well, what is the capacity? What is the amount of data? And also not just what is the amount, what is the number of files, the number of objects? The other big thing I have to think about is actually, what is the bandwidth available? Because that's going to be a huge driver to what my choice is. If I have sufficient bandwidth, hey, online is probably going to be my go-to thing. And where possible, we'd rather do it online. But if I lack the bandwidth, well, I'll have to go offline, or at least offline for the seeding of the data. Now, you might think, well, can I upgrade my bandwidth? In many countries and data centers today, it's not that hard to upgrade your bandwidth, even if it's temporary. But realize it's not just the bandwidth from your data center to Azure, Internet or Express Rail. What's your internal data center bandwidth and connectivity from the servers to the switches to the Internet or Azure egress? Hey, maybe I'll upgrade my bandwidth to whatever, but I've got a 1 gigabit Ethernet connection on my source. It's a legacy server, in which case I'm stuck. That doesn't help a lot of things. Also, some companies would rather do the major seeding offline. They don't want to use their bandwidth. And again, anytime we use the word offline, we're really thinking about Azure Data Box. But the other big thing I have to think about is this churn. What is the rate of change? If the churn is very high, and if the capacity was fairly high, depending on my bandwidth, I may never be able to get the data copied. Like, I'll never be able to catch up. So these things can be major factors in what I need to do. Potentially, if it was so high, even if I do an offline seed, remember, they're going to ship me a box. I have to copy the data to it. I ship the box back, and they hydrate it into my storage account. If my data is refreshing and completely being changed every 3 or 4 days, by the time they've restored it with DataBox, all the data is changed. This is useless. So then that's not an option. I have to have some way to do it online, or find some way to split where the transactions are being written. Hey, the new data, can it write the new data to the on-prem and write it to the target? So then I don't actually do a migration as such. I just duplicate where all the writes are happening. So there's not necessarily an easy, this is the answer, but I have to understand all of these elements to help me decide what is the right path to actually solve this for me. Okay, so now we can think about, well, what are the solutions I can use? And once again, we're going to jump over for a second. There's a nice little page here. So there is an Azure Storage Migrations page, and it goes through what the different solutions are. It talks about Azure Storage Mover, Azure Data Box, not really going to focus on Azure Migrate, and Azure File Sync. So those are the big 3 Microsoft ones. And if I think about this for a second, if I think about the how, so let's stay on the how for a second. So Microsoft solutions, so they have Azure File Sync. This uses an agent that I install on my Windows file servers, and that's what it supports. When I think of Azure File Sync, this is Windows file-based SMB going to Azure Files. That's what it supports. The other major solution they have is Azure Storage Mover. Azure Storage Mover is an appliance. So this appliance will be installed based on a VM image into your environment. It has to have line of sight to all of your source servers, and then it facilitates the movement of the data. In terms of what this supports, well, this supports NFS, can go to blob, SMB, you're probably going to guess it, can go to Azure Files. So it's aimed at those scenarios where, hey, we can jump over and look, file-based services. So if we look at the Azure Storage Mover, it goes through what it is, but it primarily is telling you, hey, SMB goes to Azure File Shares, NFS 3 and 4 go to an Azure Blob storage container. Now it has a lot of nice capabilities. It talks about, hey, that agent component that has to have line of sight, which then moves it into the targets. It's a fully managed service. It can integrate with Azure Databox, so it could do that seeding capabilities via Databox and then catch up. Obviously, these are free solutions. I guess I have to mention it. You also do have from Microsoft AZ copy, maybe even robo copy. That's a stretch. You don't normally use them for storage migrations. Mainly because they lack the rich capabilities of the other solutions. And also, it might seem really simple, but as soon as you have a problem, as soon as you hit some barrier, they're really hard to solve that problem. It's better to use a proper migration solution. And so, hey, if it is a Windows SMB, this is just synchronizing it to a cloud endpoint, your Azure File Share, and many, many file servers. This is, again, just focused on, hey, I just want to be able to move from SMB or NFS. These mentioned, I can use it with Databox to do that offline seeding. So if I'm thinking about which of these to use, if it's matching these targets, it's not super high churn, then I'm probably going to use Azure Storage Mover. Not too bad at all. If my data estate is well understood, if it's properly structured, the Microsoft tools are generally going to be fine. They should probably meet your requirements. But if you're not in that scenario, for all the other cases, maybe I want a better upfront assessment, I have a high churn, I have richer requirements for how I'm doing the mappings, I'm not in this nice little neat matching of what we have, then we get into a different program entirely. This is still provided by Microsoft, but I guess we'll change the color just a little bit. This is the Storage Migration Program. Now, what the Storage Migration Program is actually select ISV tools. So these are tools from a third party, but it's offsetting the license cost. Microsoft are basically paying the bill, providing it is new Azure data. So it's net new. So, hey, I'm going to move this X amount of data into Azure. It's net new storage to Azure. Microsoft will pay for these select ISV tools to be used as part of that migration, because then they get the yummy, yummy data in Azure. I don't know if you see yummy, yummy. So this is the details about the Storage Migration Program. So it's telling you, hey, we have native tools, but as we talked about the tool comparisons, there were all these times where the answers were kind of no on the Microsoft tooling and yes on the third parties. So if you're in this scenario where it's a no and I need it to be a yes, well, now I can use these third-party tools. And the point is, for these toolings, They're free to use. I can leverage these capabilities to perform the migration for me. And it talks about the different scenarios these support. And they keep it pretty well up to date. And there's a whole fact, is it really free? Yes, it's really free. For the migration, again, it's doing caveats. If I want like ongoing replication, then no. This is for a one-time migration. And it goes through sort of how you do this, how you can go and get more data, etc., etc. But what's really nice about this is where it was a no, well, now essentially it becomes a yes, and it doesn't cost you any money. Now, there's still going to be other times where maybe those select tools don't meet all of the requirements. So there are still third-party tools outside of that. So there's also third-party migration tools. Now, obviously, I'm going to use this because it maybe has richer features. It does something even these ones in this program do not do, but I'm going to pay. At this point, this is Microsoft not funding these tools. You're paying. So it's going to cost you dollars, but depending on these richer features, for example, let's say it's got more advanced tiering capabilities. So it's going to assess what I have right now, and instead of just moving it to one tier, it will put this stuff in archive, this stuff in cold, this stuff in cool, this stuff in hot, whatever that combination might be. So it may actually then save you more dollars. So it may be worth spending the money on the license to actually save money on the all-up total solution. And I thought it might be interesting just to quickly show an example of one of these. So if we jump over for a second. So this is the Komprise tool. So again, this is what you could access for free as part of the program when you're migrating it. The way this works is it's an agent. So what you're going to deploy is n number of virtual machines. If I go and look at my site, so I define the sites I have, you're going to deploy observers. So the observers have line of sight to your data sources, which will then go and talk to the Komprise cloud service. Now, cloud service includes this console. So here you can see I've got two observers set up. It does some initial tests to understand the available bandwidth, the latency, to understand the transfer rates. And then I would go through, and once I've done this, I have my data stores. So both my source and my target solutions. So it's got Amazon and Azure here, but it has huge ranges of different types of storage solutions. And the reason it calls them out as separate is it understands and uses the native APIs of these various platforms to go and connect and do discovery so we can get as much information as possible. So the volumes that exist, the shares that exist, the size, the number of items, you obviously give it a credential to go and do this. It's important to note that when I'm doing this, no data is sent to Komprise, only the information about the data, which lets you then see, how much data there is, percentage of what is cold based on our configurations. So it's giving me the info I have around the various volumes and the storage I have. And then there's a whole set of very rich, there's a deep analysis capabilities. I can go and plan. I can get detailed reporting of everything I have and I've got. But for the most part, we're going to go and perform a migration. And you can see they've actually got them running here. And they run iterations. So you can see, for example, this one is on iteration 4,500 because it's keeping it synchronized as part of my migration effort. If I look at it, you'll notice I can do things like define the source, what the protocols are. There's different options I have around the configuration. There's various logs and audits that I can see as part of this. It's showing me what it's doing in each of the iterations. It's the amount of data it's copied, how long it took, when it started, when it ended. So I've got full insight. I could look at some of the basic settings around it. So is the source set to be read-only? Do I preserve access time? Do I want to use snapshots? It will understand if the data is already there. And then I can opt to should it overwrite it, should it leave it alone. So I could do seeding, for example, with Databox as part of this. Should it migrate automatically as soon as you go and create the job? Validations. There's whole sets of really advanced options and visibility I get depending on what I need. But my whole point in showing this is just there's a massive amount of capability in these third-party solutions that if it's net new data to Azure, I can use for free. So don't think, hey, I'm going to limit myself just to like Azure Storage Mover, which may be the right solution. Again, if it's very well understood, it's a basic scenario, great. But if I have those more complex requirements based on that comparison chart, don't limit yourself. Absolutely, you can go and use these third-party tools. So that was it. I mean, that's what I really wanted to focus on as part of this video. I wanted to keep it as high level as possible because it depends always in any kind of migration or architecture. In the description, I have the links to all those different articles that I've showed here. But just take the time up front, understand what it is I need, understand what I'm going to want out of my solution. Then we have all these different targets. Again, if I'm cloud first, I'm starting from scratch, probably blob. If it's analytics, it's going to drive me to turn on the hierarchical namespace and use the Azure Data Lake Storage Gen 2. If I have to have more of a legacy, I can't change it. If it's file-based, and it's Azure Files or Azure NetApp Files, if I have more advanced performance or requirements. If I'm high-performance computing, it's just going to be Lustre or maybe some other third-party tool. If I'm moving a block, then I'm probably going to want to mount it into some VM, Azure Disk initially. And if I'm going to modernize, remember, it's generally easier to just modernize move it as is first, and then modernize in the cloud. It lets me get rid of the legacy stuff quicker and start taking advantage of the tools in Azure to actually do the migration super low latency. Most of the time, we'd rather do an online migration, but if it's too much, or I even want to just do an offline seed, Azure Databox is a really great way to move that data offline. And then, hey, the Delta I can use online. Lots of different tools available. If I can use the Microsoft tools because it's a more simple, more direct mapping, great. But if not, there's a lot of really great third-party tools I can use for free as part of the storage migration program, providing it's net new data to Azure. But there are also third-party tools that I'll have to pay for, but if their advanced capabilities would then maybe save us more money, it may be worth paying the license. So I hope that was useful. As always, till next video, take care.